All right, so here, everything we've been doing so far has been real visual. Okay, we're drawing arrows from this point to this point and doing a lot on the graph and that kind of thing. It's all geometric, okay? Do want to make sure that we understand the algebra involved. And this is what we did. We didn't do as much geometric stuff last year. We did a lot of this last year. So that's why we're able to go through this relatively quickly. We have this vector, and remember we had horizontal and vertical components. All right, in this case they're called V1 and V2. All right, notice here we have regular vector notation with some parentheses. Here we have, what do we call this notation? Unit vector notation with the I and the J vector. Okay. So the magnitude or length of the vector is given by this notation, okay? Now, you may in some cases see it written. IB does not normally do this, but you may see this written with the double vertical line on either side, okay? So you might see that. IB typically sticks to just this, but I wanted you to be aware if you see it written otherwise. But where does that come from? Where does this formula for magnitude come from?
That's the distance formula.
Distance formula, and distance formula was derived from the Pythagorean theorem, okay? Because here's what we have. V1 is our horizontal component. It's the magnitude or length of that horizontal component. And V2 is the vertical component. And the magnitude of V is what we are trying to find here. Okay? So vertical and horizontal are perpendicular to each other, so we've got a right triangle, and this is just the Pythagorean theorem. Okay? It's just the Pythagorean theorem. So that's pretty simple. Okay? We also, in the past, have had vector addition. And really what I want to do is just kind of, these are here, and we're going to try some, again, just to jog your memory, since we did do this a bit last year. All right, so here we have U is 4, -3, and V is 1, 6. And notice what we're doing here. We're going to add the horizontal components, all right? So when I do U plus V, I'm going to add the horizontal components, 4 and 1, and I'm going to add the vertical components, -3 and 6. And I then get my resultant vector, 4, 3. Okay? Any questions so far?
Can you just leave this up for 1 second?
Okay. We're doing fine. All right, so here we have our vector addition. We also have scalar multiplication. And in scalar multiplication, we're simply going to multiply each of the coefficients by whatever number our vector is multiplied by. So using V above here is 1, 6. If I had 5V, I would be multiplying 5 times the 1 and 5 times the 6, and that would give me 530 as my new vector. Okay? You think about this in terms of force or something like that. Let's say force, you know, you've got one person who's pulling at this vector, if you had 5 people of equal strength pulling at this vector, this would be the result. Okay? It's just multiplying that vector. Okay? So let's try putting some of this together. Okay? Let's try putting some together here. Here's a vector u and v. Vector u is 4, -3. Vector v is 1, 6. Try to find 2u minus 3v, kind of combining what we just looked at with scalar multiplication and with addition. And then hence, okay, which remember, hence means use your result from the previous one. Hence, find this. What is this asking you to find? The magnitude, okay? So take a minute here and try that.
It is the same thing. What's the difference?
I need to go upstairs to repair that drawer.
I think this is really
And my old school we used to call those the iPad zeros. We're like, we're gonna use the iPad zeros today.
And in my middle school, our teacher, instead of grading on homework, we would have a whiteboard quiz every day, and that was how he assessed if you did it or not. Because he didn't care if you did or you cared if you just did. So if you did the whiteboard quiz right, nothing was checked. If you failed your whiteboard quiz,
The best was my 7th grade. They had the student assigned homework checking. And there was like an unwritten rule where everyone just gives credit to everyone. And then one day, I was checking homework and everyone was like,
what's jingle?
basically no one ever checked the homework checker's homework, which is part of the rule. And this one kid was just like, hey, Miss Bromberg, can you check Alex's homework? And everyone's just like, kidding me right now? This is another chance.
So 24 times 24 is
596, I think.
let's see.
Wait, is the magnitude the absolute?
76.
576.
576.
Oh.
Okay, that's gonna be ugly.
24 squared.
Is it?
If you got that far.
Okay. Alright, so you got 2u.
What is 24 squared?
Alright, what's 2u?
5, comma, -24.
No, so you would be 8.
Oh, you're giving me the whole answer. Just 2u.
Is 5?
8.
8, sorry.
8 and 6. That's okay.
Sorry.
New ways.
I'm stuck up.
And then minus, what's 3b?
318.
318. By the way, you can multiply it by a -3 and then you're adding the vectors, or you can multiply it by 3 and then subtract. Either way, you'll get the same thing. Just don't multiply it by -3 and then subtract.
Wait, so do we have to like solve?
So, well, now you're solving. So now what did you have?
5, -24.
5, -24. There you go. You had the right answer. So, all right. So there's what we have. 2u is this, minus 3v is that, is 5, -24. Okay?
Let's stop writing.
And then if we're finding the magnitude of 2u minus 3v, what are we doing?
5 squared plus -24 squared.
5 squared plus a -24 squared, square rooted, right?
Which is, so the
So if you get 601 square rooted, and then, which is approximately 24.52.
All right, good. And guys, did you hear what she said? It's approximately 24.52. A couple things. Get used to rounding to 2 decimals. Okay, the 2 decimals.
Which ones which ones do you use for magnitude?
You can do either one. You can leave it in radical form, or you can write it as a decimal to do decimal places. Okay. If you do decimal to 2 decimal places, though, round to. Make sure you round. Okay. Also, as you guys think forward to your IA when you're writing, one thing to kind of earn you, brownie points with the reader. Not that they'll necessarily dock you heavily for this, but if you use approximately when you're rounding as opposed to saying equals, it shows a better understanding of what's going on. So that, the whole thing impacts the reader's impression of you as a student. Okay? So, all right, any questions about that? Comments, anything? Okay, the last little thing was finding a vector from one point to another. Okay? If I want the vector from A to B, yeah. The vector from A to B, you can see here what the formula is. Subtract the coordinates, the horizontal components, the horizontal coordinates and the vertical coordinates, but notice the order, because order matters here. If you get them in the wrong order, then you'll have your vector going the wrong direction. All right, so notice it says do x2 minus x1. All right? So, x2 is from the point you're going to. All right? So, B here is the point 5,4. I'm going to 5 from a negative 4. So, yeah, 5 minus a negative 4, 5 plus 4. So, I know the horizontal component of this vector is 9. And then I'm going to 4 from 6, so that's a negative 2. Okay? So you can use the formula. I recommend, though, thinking a little bit about movement. Okay? Think of it in terms of movement. To get from a negative 4 over to a positive 5, you have to move 9 in the positive direction, right? And to get from a 6 down to a 4, you've got to go down 2. What algebra concept is this? Essentially?
Slope.
Slope. All right? Think in terms of slope. Think in terms of rise and run. And the only difference is we write it as a vector, not a ratio, and you wouldn't reduce anything. What would reducing do? You'd be dividing the vector and changing the magnitude. You'd have the direction right, but your magnitude would get messed up. Okay? So, all right, so that's really it. And we have covered in 2 days the first 6 sections of chapter 12. So, we're doing great. Okay? There's some practice, again, just a few here and there from the different sections. Another thing I'll say, okay, please try some from each problem, okay? But, particularly on ones that have, a whole bunch of different sections, if you do a couple of the parts and you're really getting it like these especially, okay? If you do, A and B and that's easy, maybe do F or E and F or something. If you skip some of the middle ones, that's okay. But definitely at least do the last ones in each one. All right, if you look at it you're like, oh, I know how to do that, at least do E and F to get the practice with the most challenging ones. The other thing here I'll point out, what's a unit vector again from yesterday? I and J are examples of unit vectors, specific ones. They're the horizontal and vertical unit vectors, but the general term unit vector refers to a vector, what? No?
It's the vector with one for the y component, one for the x component.
Oh, it starts with the origin?
You multiply it by the other stuff in order.
Again, those are specifics. That's a specific, I and J are a specific horizontal and vertical unit vector. But the general term unit vector simply is referring to a vector whose magnitude equals 1. Okay? So here, for these, here you're solving for k, here you're testing to see if the magnitude equals 1. Here you're solving for k to force the magnitude to equal 1. Okay? So, keep that in mind as you work through those. Okay?
Okay.
All right.